Welcome to the 71st video in our series about Unix tools. In this video, I'll show you how Makefile, if I can spell it right, I'll show you a Makefile that creates a static library and uses it. The demo program computes sine of x, as you saw in the previous video. It's the same dependency tree. So if you didn't look at it last time, pause the video, look at it this time. Okay, we have to convert that graph into Makefile format. I showed you how to do that in another video. Here it is. Just each time you have left-hand side and you got the right-hand side. Okay, left-hand side, and then this and this form the right-hand side. Left-hand side, these two form the right-hand side. It's pretty simple, and you need to sort these so that for .o files, the .c file is first in the list. The headers can be in any order, it doesn't matter, but you need this .c file to be first. And when you do your link up here, you need to make sure you list whichever one is the object file that has main, and you should make that first. So, cool. We see how to do that. Please remember, after each one of these colons, you need in here, that's got to be a tab, a real tab, not spaces. If you're using VIM, and you should be, after all my wonderful videos about it, you'll need to set no expand tab to make sure that you disable the automatic tab replacement. Normally, you're doing Python, you're doing C, you don't want any tabs. But Makefile uses tab as a separator. It has to have tabs here and here and here. And if you don't have a tab, if you use spaces, it's going to break. Okay, after you have the structure created, the next step is to add the actual recipes or rules that are necessary to rebuild each one of these targets, right? Those are called the targets. In the tree, they'd be called nodes. So, great. Let's take a look. I have a Makefile right here. You see it's not too big, 659. It's only 34 lines. And wow, a lot of new stuff. And you think, well, it's not too much new stuff. If you look at this, this is pretty much the same way we built our .os in the other video, which you should have already watched. The only thing that's different is I've added some C flags here. I have a clean target just like last time, and I have a distclean that depends on clean. And the difference between clean and distclean is clean is going to remove object files. Distclean will also remove the library and the application. Okay, I don't see anything too complicated. I see something new here though. This is a strip. Strip is a program that removes debug information. It removes everything that's not required to actually run the program. So that's what strip does. It makes your executable, your binary executable file smaller. And then here's the magic. Okay, how to create libmylib, and you have it depend on all the .os. And you're going to call the AR program, and you say, what? I don't know AR. Sure you do. We used it in the last video. But here I've put it in a variable so that if I used some other tool that worked the same way, I would just change it once up here. And then I've got the R option, and then .at, remember that points to the target. What is $question? That's something new. We use dollar less than, which is the first dependency. We use dollar hat to say all the dependencies. What's dollar question? Dollar question is all the dependencies that are newer than the target. If the target doesn't exist, that's all the dependencies, and it's the same as dollar hat. But let's say you already had libmylib and you only changed factorial like we did in the previous video. Dollar question will say factorial, but it will not say Taylor sign because Taylor sign will be older than this. Finally, we had to call ranlib, and again, I've just put it into a variable, so if I use some other tool than ranlib, I just have to change it in one place. All my tools, AR, ranlib, GCC, they're all up at the top. And then I give the target name. Here's the link. Now we do have something new. I've got some linker flags, but the rest pretty simple. Take the first one. That's why I said list the object file with main. And then I output the target. And here's the stuff you saw in video number 70. Remember, if it's called libmylib.a, you forget the lib and you forget the .a and you use mylib, which is what you see right there. Finally, I have a trailing libs, and that has the -lm. Sometimes you need more than lm. There's a imvec for vectorized stuff. We don't need it in this program, but by using this variable, I only need to change it in one place. And you say, Mr. Ham, I only build one executable. Yes, right now, but these make files tend to grow. You know, you start a project, there's only one executable, but then somebody wants another executable that's part of the same project. Well, then you'll have more than one link in your file. Okay. What are all these options? I could go through it, but the truth is you probably don't care. We're trying to learn the make file. They're just some options, okay? And whatever they are, they're going to be put in here. Fill in these blanks. But you can see that the basic structure, except for the clean and distclean, but the basic structure matches the ASCII art ugly graph I made, and I have the rules, and the .o rules are simple. They didn't change. The archive rules, they're pretty simple. And finally, the link. I've added the strip, but that's all. Okay, let's run it. Right now you can see, if you look at the screen, there are no .o files, there's no .a file, and tested hasn't been built. So this should do a full rebuild of everything. And it does. And you see, it does it in the right order too. It creates tested, Taylor sign, factorial, and then it says, ooh, time to make the archive, and it makes the archive, and then it tells you, I'm creating the archive. Then we run the indexer, and at that point, we've done it all, and so we can do the big link. And again, GCC here, you know, we've got some options, but here's our file that has main. We output it to test it. We do the -l dot -l mylib to access the libmylib.a static library routines. We do the -lm so we can use the system sign. And finally, I do a strip with the -s option, which is aggressive. It removes everything it can. And I've got tested. And if we take a look, tested's still pretty big because I built a static executable. If I do a make clean, you'll see the static libraries there ready to use, and the header files are there ready to use. And we've still got the executable. If I make distclean, they're gone too. So, let me put it back on the screen. If I can spell. It's not magic. It's not all that difficult. You just have to learn how to do it. I should tell you about this line at the top, though. This line says, do not use any built-in automatic rules. Only do what I tell you to do. I'm going to be stressing that you should put this at the top of every makefile. Never let the computer guess. You need to tell the computer exactly what you want it to do. Please don't let it guess. When it guesses, it'll work right for months. And then one night at 4 a.m. when you really need it, it'll guess wrong. If you put the dot suffixes in, yes, the first few days are difficult because you have to put the complete tree, every single dependency, and you have to keep them up to date. But in the long run, it won't break. So I recommend dot suffixes, and by having it empty, that says no built-in makefile rules. Only do what I tell you to do in this file that you can see. Okay, we've reached our time limit for this video. I want to thank you for sticking with it. In our next video, I'm going to do something with shared libraries. So if you don't like static libraries, come back next time. I'll show you a shared library. But until then, thank you for listening.